This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The third type of question you might be asked when you're asked to find the equation of a circle is to find it given 2 points and the equation of a tangent at one of these points. So in the example I have here, we are told that the line 2x minus y minus 17 equals 0 is a tangent to the circle K at the point 6 minus 5, and we are also told that the circle contains the point 4, 1, and we want to find the equation of the circle K. So just like our previous examples, first things first, we write down our general equation, and what we're looking to find is 3 equations to help us get our G, our F, and our C. So we're told initially that we have 2 points that are on the circle, 6 minus 5 and 4, 1. So the first thing we can do is fill in those x and y values into our equations, into our main equation. Filling in the point 6 minus 5, x is 6, y is minus 5, and so on. We end up with our first equation, call it equation 1, 12g minus 10f plus c equals minus 61. So that's equation 1. Filling in our point 4, 1, so x is 4, y is 1, we get a second equation, 8g plus 2f plus c equals minus 17. Call that equation 2. And now the last thing we need to deal with is this tangent line 2x minus y minus 17 equals 0. So what we're going to do is, first of all, we're going to find the slope of the tangent line. So here I've rewritten the equation of our tangent line, and to get the slope we recall that the formula is minus a over b. And when we do that, we find that our a is 2, our b is minus 1, so our slope is going to be 2. And if we get the perpendicular slope to that, we get a slope of minus 1 over 2. The reason for this is we're told that the point of contact between the circle and the tangent is 6 minus 5. So if we were to draw a circle and a tangent to the circle, if we can figure out the equation of the line perpendicular to this tangent at that point of contact, then we know from our geometry that a line perpendicular to a tangent at the point of contact will always pass through the center of the circle. So, using this fact here, we're going to be able to find the center, the equation of this red line down along here, which passes through our center, and we know the center of a circle with this form is minus g minus f, so kind of similar to the previous example, we can fill in our minus g minus f. So just one step at a time, we know the slope of the equation going through the center. It was minus a half. We know a point on that line, the point of contact, 6 minus 5, so this point here is 6 minus 5. So the equation then, the equation of the line is y minus y1 equals m times x minus x1. So our y1 is minus 5, so we get y plus 5 equals our m is minus a half, x minus x1, so minus 6. Multiplying this by 2 to get rid of this fraction, we get 2y plus 10 is equal to minus x plus 6, because minus 1 times x is minus x, minus 1 times minus 6 is plus 6. Bringing everything to one side, we get the equation through the center of x plus 2y plus 4 equals 0. So that's this red line here that I was talking about. And we know that the center will be on that line. So our center minus g minus f will be on that line. So that means we can have our x is minus g, our y is minus f. So minus g plus 2 times minus f plus 4 equals 0. So we get our third equation, which is minus g minus 2f equals minus 4, and we'll call that equation 3. So now I've just grouped my equations together here. So I had my equation 1, 2, and 3 from the previous slide here. So our next step is to solve these simultaneously. We notice again that our third equation has no c component. So if we get rid of the c up here, we can use our simultaneous equations to find g and f. So if we take our first equation as it is and change the sign all the way across our second equation, so 8g becomes minus 8g, 2f becomes a minus 2f, plus c becomes minus c, and minus 17 becomes plus 17. Adding these two equations together, we see that our c's cancel, and we have minus 12, we have 12 minus 8 gives us 4g, minus 10 minus 2 gives us minus 12f, minus 61 plus 17 gives us minus 44. Then we take down our third equation to here, and we have two equations now that have just g and f in them. So if we want to get rid of, say, g here, we'll have to multiply our second equation by 4. So when we do that, our first equation stays the same. So 4g minus 12f is equal to minus 44. Multiplying everything across here by 4, we have minus 4g minus 8f, and 4 times minus 4 is minus 16. Then we have two equations that we can add together. So the 4g cancels with a minus 4g. And we have minus 12 minus 8 gives us minus 20f. Minus 44 minus 16 gives us minus 60. So f is equal to 3. Then we can take that value for f and we can substitute it into one of our equations. So here I've taken equation 3, which was minus g minus 2f equals minus 4, filling in our value of 3 for f here, and simplifying that down, we find that minus g is equal to 2, or dividing both sides by minus 1, minus g, or g is equal to minus 2. So now what we have is we have f and g. If we take, say, equation 1, we can fill in those values of f and the value for g into this, so g becomes a minus 2, f becomes a 3, and we can simplify down our expression to eventually find that c is equal to minus 7. So then all we have to do is take our general form here and fill in our values for g, f, and c. So g is minus 2, f is 3, c is minus 7. Filling those values in and simplifying our expression, we find that the equation we're looking for is x squared plus y squared minus 4x plus 6y minus 7 equals 0.